Hey folks, welcome to another Triple T Thursday. For those just joining us, that's Tools, Tips, and Talk, where we'll discuss info for the knife maker. In today's episode, we're going to start a new series. It's going to be another folder. This time it's going to be a compression lock folder. If you're not sure what that is, stay tuned and learn how to build it. I'll have plans for this up on my website. Also, if you're a Patreon member, you can download the plans for this from Patreon for free. So definitely go check that out if you're not a member. We're going to start this episode up in the office. We're going to take a look at the design in knife print and see how we're going to make it. So if you're not familiar with knife print, that's what I use for folders. I think it's really great. You can design your folders easily. And the best part is they have a pivot option. So after you put your pivot, you can just rotate the blade and ensure that everything is going to work. And you can also have layers and put your liner and your blades on different layers so that you can export those as DXFs or PDFs. But really cool feature. But let's get into with the design we're going to talk about today. Okay, before we get into the new design for the compression lock, I wanted to remind folks how a regular liner lock works. So here we have the liner. This is the lock portion. This lock will get bent over so that when the blade, so right now is in the closed position, when the blade is opened, it will hit the stop pin, and now, the lock will engage against this surface of the blade, thus locking it. Then to release the lock, someone would push the lock with their thumb, okay, release the lock, and then you can close the blade. So one issue with this is that the blade is essentially closing on your fingers if you're not careful, and will close back here. It does require that you get your hand out of the way. Now let's go look at the compression lock and see how that's different. So here we have my design for the compression lock, and this is based on my SilverTip EDC design, so that's the blade shape here. But a little different. I'm just going to hide some of the parts here so we can easily see the liner. So you'll notice that the liner, the lock area is kind of more of a cutout here. And there's a reason for this. If we show the blade, the lock face is this part of the blade here. I'll zoom in a little bit. So this area here, okay, on the blade is going to be our lock surface. If I show this, this is our lock surface. Okay, this plane right here. Here we are in the closed position, but as I rotate the blade, okay, this portion is going to hit the stop pin up here. Okay, this is just a set, but it'll actually be an 1/8 inch, so it'll hit the stop pin, and then the lock, just like in a liner lock, will pop and be secured against this portion of the blade. The difference is now the lock release is on the spine, so you don't get your fingers in the way, and you can actually release this just with the your thumb on the top of the blade. So it's actually kind of cool. You can release this. You can even open the blade just by releasing the lock, which is going to release the detent, which is over here. So kind of a cool design. This design was originally done by Spyderco. And they patented it, but that patent expired in 2021. So we're going to make this in this design. And just a bit more about this design and how I use it. I actually export these as DXFs and I use my laser. So I like to spot all of these areas with holes that I can use my optical center punch to drill. So this would be the pivot. This one and these 4 are going to be for the screws for the bolsters, screws for the scales. These are just end points for cutting out the lock, for the stop pin, and this is for the back bar. So I like to set all those like this so that I'm ready to drill those once I get the this pattern lasered on the titanium. All right, I'm going to go do that, and we'll take a look at what we got. So here are the pieces that I lasered just to get the patterns on them, the blade, and then 2 pieces of titanium. I've also just drawn lines on where the lock is because I'm going to be drilling every one of the other holes through both of these. And I don't want those holes through both of them because that's just for the lock side. So the way I do this is I'm going to drill, because I need to get these right over top perfectly of each other. I drill through the pivot on one, drill through the pivot on the other, and then line those up with a pin, and then I can just rotate this. When I get it where I want it, I'm going to glue them together and then drill all the spot and drill all those holes through both, and then separate them and do the holes for these. All right, let's get it done. Just like in the last series, I'm using my optical center punch just to find the center of all those little holes and then mark them. Here I'm just making sure I have the dot in the center. Then I'll remove the optical portion, put the punch in, give it a whack. That'll give me perfect centers on all these holes so I can drill them easy. So I've drilled my pivot holes through both liners, and I've put a 16th inch dowel pin, and this is just so that I can put this on top and kind of line up the liners. You want to leave space around your edge here just for fit up, just in case it's not perfect. If you were to grind to these lines and then they kind of get off a little bit, then you're going to be in trouble. So I always leave extra room. In order to just match them up, I just kind of grind a little groove here so I know I can just match up the little groove here while it's pinned, and it'll be pretty accurate. So then I'm going to CA glue these together once they're pinned, and then we're going to go through all of our holes except for the holes for the lock. I do like to make sure that I use the disc grinder on the back of the liner, of the lock liner, and the front of the show liner, just to make sure those are going to be smooth. And incidentally, don't assume that the titanium is going to be perfectly flat. Here you can see that there's a little dish here where it's not really touching the disc grinder. After I get all my holes done, I'm actually going to go back and make sure that this is perfectly smooth on the inside of both of these liners. I want to take a moment and talk about our sponsor, Maritime Knife Supply. I have some exciting news. Maritime is going to have a folding knife parts section. Coming soon, probably before this series is over, you'll be able to buy all these folder parts at Maritime Knife Supply. If you're not into folders, you can still order steel, abrasives, any kind of tooling you need to make your knife making to the next level. All right, we got most of our holes drilled. Now I'm going to use a torch and just bust these apart. One thing to note, I also didn't drill through this hole here because that's the screw hole for the bolster. On this side, on the show side, that's going to be a pivot. There isn't going to be a hole here. So that's only going to be on this side, so I'll drill that along with when I drill these on the lock side. Let's get these separated. So one thing that just occurred to me, which is different, normally if this was a liner lock, this side would be the lock side because you would be pushing this out with your thumb. But because our lock's going to be at the top, we're going to want to release the lock with this finger going this way. So this is actually going to be our lock side, which is very interesting because the pivot head and the lock are on the same side. So just something to think about. Here we're drilling the stop pin, and we're using a number 32 drill, and this is solid carbide, and then we're going to move over to an 1/8 inch reamer to get exactly the thickness we need. Now I'm doing the pivot hole, starting with a number 32, going to a number 17, and then finally to a 3/16 reamer. Now I'm going to do some rough grinding on the knife profile, and then we're going to play with it in here just to make sure that our stop is correct. We'll put the stop pin in it and make sure that it stops where it's supposed to stop and closes where it's supposed to close on the same stop pin. Then we'll be able to do our back bar and kind of put it together. If you're curious why I had a 1-2-3 block on my grinder, I do that because I can bolt the 1-2-3 block to my rest, and I had this little guy, which is just a 3/8 bolt that I've drilled and reamed so that I could put this pin into it and swivel the knife around this, so it just makes it easy to do that radius. So I did a little grinding. We're going to check the stop pin now. If I swivel it, it is almost there. It just needs a little bit of a nudge to get that a little closer. And if I go this way, see, I'm quite a bit off. So I'm going to have to carefully grind this spot down right here. So we'll just keep doing it until we just creep up on it. Okay, if we check it now, the blade opens exactly where it should and closes exactly where it should. So that's great. We've done that. Next we're going to just put the back bar in it, and then we'll start to do our pivot and our bearings. We're going to be using bearings for this one. Okay, I've got our back bar done. I just ground it so that the blade would fully seat. Just with a little temporary dowel pin, the blade opens correctly and closes correctly. The last thing we're going to be doing in today's video is the bearings. In the previous build we used washers, but this time we're going to be using bearings. They just glide a little better, and yeah. So it'll make the knife have really, really nice action. The bearings I'm using are ones from TI Connector. These fit really snugly around a 3/16 pivot, and they're really narrow, which means they don't take up a lot of room around the pivot. These are Delrin cages. The black is the Delrin plastic, and these have ceramic balls, so they're very high quality bearings. Because these bearings are kind of thick compared to a washer, these are 62.5 thousandths of an inch thick as compared to the washers, which are only 15 thousandths. I want a space, a 15 thou space between the blade and the liners. So what I'm going to do is I'm going to inset the washer into the liner. We do some math here. It's 625 minus, or 62.5 minus 15, so 47 thou. We're going to inset the washer into the liner. We're going to be doing that with this specialty counter bore. So this is 360 thou wide, which is exactly what these bearings are. It just makes for a perfect fit and no play. If you want to get a more inexpensive counterbore, you can actually go with a 3/8, which is 375 thou. It just means there's a little bit of room around the bearings, but because these bearings are so tight around the pivot, a 3/8 would have been fine. So here I am at the mill. You can also do this on your drill press if you have a DRO in your drill press. The pilot on this counterbore is 3/16, which is exactly the same as our pivot hole. So there's really not a way you're going to screw this up as long as you're careful. So you just push this down and then touch here, zero your DRO. Okay, and then we're going to come up, we're going to turn it on. I'm going to put it in coil mode, and then I'm just going to go down until I'm at 47.5 thou, and that should be what we need. So here's the knife all put together with pivots, and oh, look at that, how easy that moves. I just have to tilt it, and it's gliding on those bearings. So now, next time we're going to do the bolsters so we can properly size this thing, and then we'll do the lock mechanism. So far, I'm really happy with it. Thanks, folks. We'll see you on the next one.